Hello everyone, good morning. Now in this video we are just going to understand the basic concepts of friction. At first we should know that what is friction, right? So friction is a one type of force that works in the opposite direction of the motion of an object. Suppose if there is an object which is fixed on a surface and it is having a mass of m. Suppose it is moving in this direction. So in this case, we know that the friction works in the opposite direction and along the surface in contact, right? So it is actually a relative motion of the object with respect to the surface. And the force of friction, we represent the force of friction by small f, the force of friction that resists the motion of an object. Now an object have two conditions, right? These are called the states of an object, right? States of an object. What is the two different states? One is rest, another is motion, right? So an object can be in rest or an object can be in motion. So if an object is initially at rest, suppose we are assuming an object is there who is initially at rest and it is having a mass of m, and you are applying lots of forces to move it. Okay, you are applying lots of forces to move it. Now in this case, whether the friction will be present here, obviously the friction will be present here because your applied force is not able to overcome the friction which is working along the surface like that. In this way the force of friction is working and your applied force is not able to overcome the friction force. That's why the object is at a rest. So this type of friction is known as a static friction as well, right? Where you apply lots of forces but the object cannot change its rest condition, right? That means the object is fixed at this position. Now what is the case in motion? Suppose the object is moving with a velocity of v in this way, right? The object is moving with a velocity of v in this way. So at that time of moving the friction is present over here, right? At the time of moving the friction is present over here like that. At the time of moving the friction is present like that. The friction force is represented by a. The friction force is represented by f over here. Now in both of the cases we have seen that friction force is always in the opposite direction of the motion of an object, right? Now we have seen there are the two cases of friction, right? One at the rest condition, another at the motion. Now whatever the friction, the concept of friction at the time when the object is at a rest condition, that kind of friction is known as static friction, right? Because the object is fixed at this position, the object is at rest, that's why. Now when the object is moving with a velocity of v, and at that time whatever the friction is responsible there, that kind of friction is known as dynamic friction. Dynamic friction, or you can say it is a kinetic friction, right? So you will think that in both of the friction cases, what is the difference? In both of the cases we have represented the friction force as f. Whether the friction force will be equal or which one is greater, which one is lesser. Let's see. Now at first we will analyze the case of static friction, right? At first we will analyze the case of static friction. Now in the case of static friction, what happens? Suppose there is an object and you are applying lots of forces to move it. It is having a mass of m and it is kept on the surface like that. Okay, so the friction force will obviously work in this direction, that is represented by a. Now if the object is having a mass of m, it will having a weight of m into g, and there is a normal reaction force that is equals to r. We know that the normal reaction force is equals to the weight of an object, right? Now in this case, when the object will having a more weight, more mass, then in that case the friction force will be greater. That means the friction force is directly proportional with the normal reaction force. That means I can write down that the friction force is directly proportional with the weight of the object. Now to break that proportionality, a constant will be introduced here, that is equals to mu, and I can write down the force of friction as mu mg, right? So in this case, whatever the friction force you have got, that's a one kind of static friction. Therefore, you can represent it as f of s. And in the case of mu also, you can represent it as mu of s. S for static. So the expression should be highlighted because this is one of the important expression by which some numericals can be solved. If the question is asked that find the value of static friction present over here. Now let's analyze the dynamic friction. The case is for dynamic friction. Now if we go to analyze the dynamic friction, there is the second one, that is dynamic friction, or you can say it is a kinetic friction as well, right? So in the case of kinetic friction, what do you know? Suppose there is an object who is moving in this direction with a velocity of v. It is having a mass of m. So in this case, obviously the friction force will be present over here like this way. So the friction force is represented by F. The object is having a mass of m, therefore the weight should be equals to m into g, and the normal reaction force should be equals to r. Right? Suppose you are riding a bicycle, you are just driving a car. In that case also, the friction force is present on the surface in the opposite direction of the motion of your vehicle, right, along the surface, because it's a relative motion of your vehicle with respect to the surface. So in this case also, I can represent the friction force as the friction force is directly proportional with the normal reaction force. It is directly proportional with the weight of an object. Therefore I can write down that it is equals to mu mg here. Now this is the case of dynamic or kinetic friction. So I can represent it as mu of k or mu of d also, whatever. I prefer mu of k in this case. So the expression of kinetic friction we have just got. Now if we compare these two equations, this is our equation number 1 and this is our equation number 2. If we compare these two equations, then you will see that in expression number 1, whatever the friction force you have just got here, let me write it down from 1 and 2. If we just compare, then you will see that the static friction force is obviously greater than the kinetic friction force. Why it is greater? The static friction is greater because it is, you are applying lots of forces but you are not able to overcome that friction force. That's why it is greater than the kinetic friction. Even you can say that mu of s is obviously greater than mu of k here, right? So in this way we can represent static and dynamic friction, right? Now let's move and see that what are the possible cases. We'll analyze three possible cases, right? At that time you are just applying that force and you are not able to overcome the friction. Second case, you are just applying lots of forces and at a particular time the object starts to move. And the third one, you have applied forces and the object is in acceleration. These three conditions we are just going to analyze in the next video.